All right, punks. You want to know what's going to be on the October SAT? Here are 8 question types I predict you'll see and how to solve them. Starting with exponential equations. And these are pretty easy as long as you know what is represented by your basic exponential formula. So looking here, we're always going to have some sort of a number that comes before parentheses, and this is going to be our starting point. Then in parentheses, we're going to have a number that represents our percent increase or percent decrease. And then finally, we're going to have an exponent, which represents time. So here, they're asking us to interpret 4,000. We know that 4,000 is a starting point. So let's get rid of any answers that do not look like a starting point. Initial population would be a starting point. 7 years after 2012 would not be a starting point. A percent decrease would be what's supposed to be in parentheses, so no. And D, same issue. Our answer is choice A. Next up, we've got completing the conclusion. Now, if you've watched a lot of my videos, you know that I am always encouraging you to be lazy and to ignore the graphics for these types of questions. And we want to usually start by ignoring the graphic, but this is going to be an exception to that norm. And the thing that indicates we actually need to pay attention is the fact that we are completing the student's conclusion. Because basically it says, comparing the data for bananas with and without ethylene, the student concluded that blank. So if the student is making a conclusion by comparing the data, we need to step into the shoes of the student and we need to compare the data. So basically we're gonna look at the data and we're just gonna get rid of any answer choices that are erroneous. That is to say, they don't tell us the truth. Choice A says 20 Celsius is the ideal temperature to store bananas to slow ripening time. If we look at 20 Celsius, the ripening time is gonna be the lowest of all of the options. So that's the opposite of what we want. So A is not our answer. Choice B, for those bananas that were not treated, so not treated is going to be black. Differences in temperature were not associated with absolute differences in ripening time. So basically they're saying if there was no treatment, there would be no difference based on the different temperatures. We can see that there's clearly a difference, right? The colder it is, the longer it takes for them to ripen. So that's not true. Looking at choice C, bananas treated with ethylene ripen faster at 14 and 16 than 18 and 20. Let's look at 14 and 16, so the first two. And it says treated with ethylene, so that would be the gray bar. Ripen faster. They do not, they ripen slower. 6 days, 8 days, that is slower than 5.5 days and 4 days. So that is not true. And by process of elimination, we know that D is going to be the answer. Just to go ahead and check though, it says ethylene was associated with a greater absolute change in ripening time at 14, 16, and 18 than at 20. So when it says greater absolute change in ripening time, we're basically seeing the difference between treated and untreated, right? So if we look at 14, we have 8 compared to 11, so that's 3 hours. 16, we have 6 compared to 9.5, so that's also roughly 3 hours. 18 degrees, we've got 5.5 and 8.5, so again, that's 3 hours. But then at 20, it's 4 versus 5.5, only 1.5 hours. So that's gonna be half the difference compared to those other ones. So that's what it's saying for choice D. But again, if we eliminate the first 3, it doesn't even matter, right? My next prediction is constants that hurt you. Looking at this question, for example, the constants, they hurt. We could certainly do the algebra here, but who's got time for that? You know what? Let's go ahead and get our best friend Desmos. And you might be wondering, how the heck am I supposed to use Desmos on this? Well, let me show you. We're gonna put in our equation, but we're gonna put it in as 2 separate functions. So we'll call the first one f of x, and it doesn't have to be f of x. It could be g of x or p of x or l of x or whatever, but you know, just choose one. And then we're gonna put in the left side of the equation. So that's gonna be the 12x plus 28 over 4 minus s over 13. And no, we don't need to add a slider. All right, next one, you gotta name this function different. I'll call this one b of x just because I feel like it. And that's going to be the right side of the equation, r x minus 5, 8. Cool. And no, we don't need to add a slider here either. What we do need to do is we need to say that these guys are equal to each other. Because remember, it says they're equal to each other. It has infinite many solutions. So now what we're going to do is we're going to say basically f of x equals b of x. And here's where the magic comes in. We're going to choose a constant. Any constant will do. I'm going to just go with a. We want to say f of a. So basically there's some value for x where f of x is equal. We have to use our tilde here, not our equal sign, to b of x. But again, it's going to be b of a because we're looking specifically for the x value where they're equal. And at first, it's going to tell us that s is 1 and a is 1. And this is not true because right now it's just assuming that we want these to be equal to each other when x equals 1. But we want them to be true for all values of x. And remember, a is standing in for x here. So we need to say a is equal to many, many things. Right now it says it's equal to 1, but we want to say it's equal to 1 and 2. And usually a couple numbers will do. So right now it's telling us that s is 403, which is actually our answer. But if it wasn't stabilizing, basically like if the numbers were still changing, you can just keep adding more numbers and make your list as long as it needs to be until you get consistent answers for both of your constants. But anyway, yeah, 403, that's our answer. Up next, we've got subject-verb agreement. And for subject-verb agreement, we are still using the odd verb out trick. We're going to take they. We're going to take he. We're going to ignore this. And we're going to connect they and he to our answers. For example, we would say they fascinate. We would say he has fascinated. We would say he fascinates. And we would say he is fascinating. The odd verb out is the one that connects to they because it's the only one that connects to they. So our answer is choice A. And I always get comments asking if this trick always works. I just tested it on every single new question bank question that came out about 3 weeks ago. This is one of them. And yeah, it works on every single one. So for the time being, this trick works on every subject-verb agreement question. Next, we have constants that help you. And I know what you're thinking. How could a constant possibly help me? Well, let me show you. So a lot of times, if we only have one constant, it is tempting to plug stuff in to Desmos. But for this question, I dare say it is going to be much faster if we don't, because they're giving us a really powerful piece of information here. They want us to multiply these guys together to get our answer. And while 1a is upsetting, 2a's in this situation are actually quite nice because a stands in for x. So for example, g of 15a would just be 15a over a minus 14. And then we're going to multiply that by g of 7a. So 7a over a minus 14. And yeah, if you can't see it already, this is beautiful. The a's are going to cancel out. And basically we just have 15 minus 14 times 7 minus 14. Except it's telling us a is less than 0. So rather than this turning into 15, it's going to become negative 15. Because even though the absolute value would be 15, because the denominator is negative, it ends up flipping it. And then instead of being just 7, this would be negative 7. So basically we have negative 29 times negative 21. We could certainly plug that into Desmos real quick. And then it's going to be 609 for our answer. My next prediction is
appositive imposters.
And I call these appositive imposters because they look like appositives, but they're not. Let's talk about what an appositive is real quick. If I said Robert, my favorite bald man, can play the guitar, we would have a missing A, first of all, and then we would have an appositive. My favorite bald man is an appositive that renames Robert. Basically, an appositive is something that renames or stands in for something else. Because I could instead say, my favorite bald man can play the guitar. So this becomes non-essential information. that we can get rid of. And I could either say Robert can play the guitar or my favorite bald man can play the guitar. On the contrary, if we look at the example here, we have linguist Diane Mason. Now, if I were to throw her in here and say linguist Diane Mason can play the guitar, you notice I'm not using any commas. Why not? Is this not an appositive right here? It's not. In fact, if we got rid of Diane Mason, it would say linguist can play the guitar. And we'd be wondering which linguist, because clearly there's got to be more than one linguist in the world. So basically, if we try removing the information and we're asking ourselves which one, it is an appositive imposter, in which case we want no punctuation. So choice C is our answer here. Next up, we've got the circle equation. And the circle equation, in case you've been living under a rock for the last, I don't know, however long, is going to be x minus h squared plus y minus k squared equals r squared. HK is the center of the circle and r is the radius. The only thing that might trip you up is the fact that we have minus h and minus k. So whatever we actually see is going to get flipped. So the center of this circle would be +1, -7. And that's going to be our answer for this one. And yeah, there were originally answer choices, but I wanted to just show you how easy it is to quickly get our center. Now, sure, you could use Desmos and you'd be like, oh, well, let's just find the center and we'll just zoom in here and be like, oh, what's this? Okay. Oh, that's 1, -7. And it won't be a super long process, but this is so common that you really just need to memorize it. So just memorize this formula. It comes in very handy. Don't be a nincompoop, just do it. And my final prediction for the October SAT, competing sandwiches. And there they are, ladies and gentlemen, the fighting sandwiches. So what I'm talking about is comma or dash sandwiches, as I refer to them in my English bundle courses. These are basically phrases of non-essential information, and we can get rid of them. The sentence is still going to hold up. The appositive that I mentioned earlier is going to be an example of one of these guys. So a lot of the time, not all of the time, this is a myth, it's not all the time, but a lot of the time, if you have a dash, you're going to have another dash, and it's going to create a non-essential dash sandwich. So basically, we have two different options that are going to do that for us, and we have to decide between them. Easy way to figure out which one is correct is to test both of them by getting rid of the proposed non-essential information. So choice A would sound a little something like this. Milkman's research can thus address anomalies that neoclassical economic models cannot explain. Because remember, we're getting rid of the word which there too. That sounded wonderful. My answer is choice A. And just to prove that D doesn't work, we would read it the other way, basically the same exact way, but we're also going to keep the word which. Milkman's research can thus address anomalies that neoclassical economic models which cannot explain. That doesn't sound good. That's wrong. And that's how we deal with those guys. Now, if you're serious about getting the highest possible score in English, use the link in the description for a discount on my English bundle. The courses go deep into every hack and strategy in the English section, and they include over 500 original practice questions you won't find anywhere else.